Today we're going to talk about Lesson 1-1, the language of algebra. The big idea we're going to try to talk about is algebra is a language with expressions and sentences. There are precise rules for evaluating algebraic expressions so that the meaning and values of expressions are unambiguous. Okay? You should all remember, please excuse my dear Aunt Sally, the order of operations. We're going to talk about a little bit of that. This is all just basic stuff that we learned from algebra that we're going to go over today. The language of algebra uses numbers and variables. It lets you describe patterns and relationships between quantities. A variable is a symbol that can be replaced by any one set of numbers or other objects. When variables stand for numbers, and numbers and variables are combined using operations of arithmetic. Operations of arithmetic are addition, subtraction, multiplication, and division. The result is called an algebraic expression. So when you combine arithmetic as well as numbers and variables, you get out an algebraic expression. When you simplify an algebraic expression, that's called evaluating an expression, okay? As well as algebraic expressions, we also simply call it just an expression. So if you look here, there's two pictures here. There's a picture of a triangle, which this means this side is congruent to this side by the tick mark, okay? So this side is S, so that means this side is also S. And what they want us to do is find, as well as this side is S, okay? So it's an equilateral triangle, as you should remember from geometry. To find the area of this equilateral triangle, you can use this expression, S squared times the square root of 3 all over 4 is going to give you the area of an equilateral triangle, where S is the length of the side. Here's another expression. To find volume of a cone, H is our height, R is our radius. Volume of a cone equals 1/3 pi r squared H. An algebraic sentence consists of expressions related with a verb in symbolic form. Common verbs are shown in the table at the right. Is equal to, is less than, is greater than, is less than or equal to, is greater than or equal to, is not equal to is this symbol with the slash on the equal sign, and is approximately equal to the two tildes. Okay, we all should be familiar with that. Algebraic sentences include these following symbols. Let's look at example 1. Joseph has a collection of 1,380 comic books and buys 17 new titles every month. If Joseph continues collecting comic books in this way, how many comic books will he have after M months? So M is our variable, okay? He gains so many books a month. So I always start out with what I start with. I started with 1,380 comic books. Did I gain or lose comic books? Well, it says I buy, so I assume I am gaining. So if I am gaining comic books, I am adding to my 1,380 books I already had. How many books is he gaining? Well, he's gaining 17 per month. Well, what do we use to say per month? Well, that is our variable M. So it's 17 times M, because if it was 17 times the first month, that means you'd only add 17 books. If it was 2 months, 17 times 2 would be 34, so you'd have to add 34 to 1,380. So this expression tells me how many books he has all the way out to the future. We could go 100 months. So for 100 months, all I have to do is put 100 in for M. Well, what's 1700 plus 1380? You all should be screaming at me. Dun 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 dun. 1,000, 2,000, 3,080. Comic books. Evaluating expressions, something that Mr. Johnson just did. Substituting numbers for variables in an expression and calculating a result is evaluating an expression. As soon as I put that 100 in for M, we started evaluating for that expression. We were using the standard rules for order of operations to evaluate the expression. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division from left to right, and addition and subtraction from left to right. Should have heard this plenty of times before. Let's look at this problem. It says find the value of this expression, negative b minus the square root of b squared minus 4ac all over 2a. Now, what some of you should be familiar with, that is part of the quadratic formula. It gives us the negative value. Remember, the quadratic formula is going to have a plus minus sign. This just has a negative sign. But they want us to find the value when a equals 3, b equals a negative 1, and c equals a negative 4. So this is my expression. As soon as I put these numbers in, we are evaluating the expression. So, negative b. What's b? Well, b is a negative 1. Minus the square root of b squared. So it's a negative 1 squared. Minus 4 times a is 3, times c is a negative 4. All over 2 times a. Well, what's a negative 1 times a negative 1? That's a positive 1. We use this little symbol, the square root symbol, just like a bracket, so we got to do everything inside. So a negative 1 squared is 1. Negative times a negative is a positive. 4 times 3 is 12, times 4 is 48, as you all should be saying. 2 times 3 is 6. Sorry for the penmanship. Well, what's 1 plus 48? Everybody should be saying 49. Do we know what the square root of 49 is? Square root of 49 is 7. 1 minus 7 is a negative 6. Divide it by 6. Negative 6 divided by 6 is a negative 1. Last slide. An equation is a sentence stating that two expressions are equal. Okay? An equation normally has an equal sign. Stating that these two things are equal. A formula is an equation stating that a single variable is equal to an expression with one or more different variables on the other side. So an example of a formula was our volume of that cone, which was 1/3 pi r squared h. This is a formula. Okay? That is a formula. The single variable on one side of a formula is said to be written in terms of the other variables. Below are some examples. So, if you look at this, area equals pi r squared. We would say area is written in terms of r, because pi is an actual number. Okay? Pi is an actual number, so it's just in terms of r. Looking at this one down here, y is written in terms of x is our only variable. Okay? Thank you very much. We'll see you tomorrow.